Nicholas, Joshua and
Lindo has currently recorded.
I do another one. And Josh. I changed again.
Ethan still with Justin.
Hey, Jisha, you're alone eh. My brother never come.
Thank you, hi.
我最近才，我来到这里我才发现我。
Nick and Joshua.
Please rearrange yourself to this
Where's the
sequence
homework?
later.
Okay. Then Jisha then.
Jisha, Nick, Joshua together. So maybe we can combine one chairs here.
One chair.
Alone. One chair. One chair.
Ethan move behind, then teacher can sit there.
Yeah.
My little thingy here, the thumb. Yeah, thumb. That's so soft, but it's so bad. Josephine keep my specs. Josephine I next to you.
We have different friends.
Look at
Okay.
I look so messy now. Yes. Hi, I'm back.
Okay. Last week I went a bit too fast trying to explain balancing chemical equations. So I will try to do it again, but we will recap. Okay. We have learned bonding before, and under bonding we learned that particles have to combine in a certain ways, then they will be stable. Was it okay? For example, when we say water. Okay, so this is just a recap, because anyway, this also will help you in your revisions. So for example, water, even a layman, they may know that water, the chemical formula is H2O. But if you were to ask them why H2O, I don't think they are able to explain that to you. But I'm sure we know now, because oxygen is which group? Do you have your periodic table?
Group 6.
Group 6, huh? So group 6 is this, B and I. What does group 6 means? Yeah, later. Homework. We look at the sequence, try to follow it. Okay, group 6 is what? Yeah, Nicholas is correct. Means that the outer shell, it has 6 electrons. Alright? So people like Joshua, Tisha, Xavier, you have to take note because last time your test was quite easy. It was just an MCQ, right? But this time around there is drawing as well. So the outer shell has 6 electrons, while hydrogen actually has only 1. Alright? So the next question is, how many does oxygen need to be stable? Oxygen need how many more? Joshua, is it? Yeah. So oxygen needs 2 more. So how many oxygen willing to share? 2. Yes, correct. So oxygen willing to share 2. Alright? So when you say sharing, it means that, for example, when the oxygen is here, and there is a circle around it, alright? And there is a hydrogen, as you mentioned here, there's 2 hydrogens. So there will be 1 hydrogen here, and 1 hydrogen here. Alright, so this is hydrogen, this is hydrogen. So this place is called the sharing zone. So this is where the sharing zone is. So how many were you able to see the electrons contributed by the oxygen in each sharing zone? 1, yeah, 1 each, correct. So let's say that the cross means that the electrons of oxygen, so you'll see 1 each in the sharing zone. So the rest of the other 4 will be outside, you will not be in the sharing zone. Was it okay? Then how about hydrogen? Hydrogen has only 1 electron, so it's willing to share 1 only, correct? So let's just say that now the dot is the electrons of hydrogen. So therefore, in the sharing zones, you will see this. Correct? So therefore, when we look at chemical equations, you cannot disturb the chemical formulas. It is already fixed. And why is it fixed? It's fixed because of the bonding. Was it okay? So basically means that when you say H2O, it has to be H2O. It cannot be H2O2, it cannot be H2O4. I mean, it's possible, but it becomes a totally different compound altogether. Is it okay? Can. So that knowledge itself, you only need a copy. Only, right? Okay. So anyone knows about what is H2O2?
Hydrogen peroxide.
Correct. This is known. So you see, once you change the name, this is not a water anymore. So this has a different name altogether. This is hydrogen peroxide, and in fact, this one is a poison in our body.
But sometimes it also used
Yeah, produce
for cleaning wounds.
Yes, correct. Because it's toxic. It's supposed to help us to kill the bacteria. So I asked the questions. What is H2O?
Water.
Water. So what is H2O2?
Oxygen.
So what is H2O4?
For drinking.
Yeah, H2O for drinking. Because I was asking what is H2O for.
H2O4.
I
Just got a joke for the.
I heard on the group before, so I know.
No, there's another joke
Huh?
about the hydrogen peroxide.
Okay, Ken?
No.
Yeah, the two scientists. Right?
Yeah.
Yeah.
Done? Ken? Have you all copy finished?
H2O4. Drinking
Huh? H2O what? It's one H at the end, and then the one. It's two O's connected, right?
Understand.
Okay, yeah? Is it okay?
You
Alright. Important part of balancing chemical equation. For example, let's say that you have a carbon reacting with oxygen, and then you form a compound called carbon monoxide.
Huh?
Okay? So for example, you cannot change, alright? You cannot change the numbers here. Alright? You cannot change the number. So basically, if this is O2, it means you will be an O2. So you cannot change this number to just O. Or you cannot change this to 5. You cannot change this to 6 or any other number, because if it's O2, you will be O2. Was it okay? So now I'm trying to use a pictures. Okay? So for example, carbon is a girl. Alright? So here there is a girl with a little boy. Is it okay? So the oxygen is the little boy here. So there is two little boy here holding hands.
Holding
Is it okay?
Because she must.
Yeah, they have to hold hands. Maybe if you say it's a double bond, then maybe they hold two hands. So this is what actually happens. There is one lady here, and there are two boys here. Okay, they went, say, shopping. Alright, so maybe they went to Ion.
Ion?
Okay, so they came out. There's one boy missing, and that's of course is quite worrying. But imagine that this is what happens before you enter into a shopping mall, and after you enter the shopping mall, the total number of ladies and the total number of young boys must be the same. Alright? Okay? So, but there's a requirement. This lady, after he came out from the shopping mall, he can only hold one boy's hand. Okay, how to hold the hand like that? Okay. Alright? So then how? How are you going to actually make sure that when the two boys come in, they have to hold hands too? So when you count, there's only one lady here, there are two boys here, there's one lady here, and there's one boy here. So how are you going to
put a 2 in front of the C.
put a two? Yeah, so means that you have to say that, okay, since now there's every one lady with a boy, correct? So now there's two boys here, maybe I add another lady here. Correct? So then it's possible that one lady hold one boy's hand, one lady hold one boy's hand. Am I correct? But here, if you count, there are total how many? There are 2 C and there are 2 oxygen here. But here, what's the total? There is only 1 C and there is only 1 oxygen.
So put a 2 there.
So we're going to say that, why not pick 2 pairs? Correct? So therefore, there will be 2C and there will be 2O. Does it make sense? Means that when the total number of people going into a shopping mall has to be the same as the total number of people that comes out from the shopping center. So how do you balance it? So you put a 2 here and you put a 2 here. Anyone lost in a shopping mall? Huh? So basically, is you cannot disturb this chemical number. You can only tell multiples of this. For example, multiples of this carbon, multiples of the oxygen, or the multiples of the carbon monoxide. Okay. So if you all no question, I'm going to change and I'll let Jisha try this. Okay, Jisha, let's take a look at this. Okay, Jisha, can you tell me before the reactions how many zinc are there? So this is before. This is before. This is after. Okay, so Jisha, can you tell me how many zinc are here? Just by looking at here. You don't need to look at the periodic table. How many zinc are here? How many? One, correct. So there's one Zn. How many H are there?
One.
One. And one number, how many Cl are there?
One.
One. Okay, very good. After, how many zinc are there?
One.
One. How many H are there?
Two.
Two. Very good. And how many Cl are there?
Two.
Two. So my question is the total number of all these elements the same as here?
No.
Why?
Because there's more H.
More H?
Yeah, and there's also more
Cl. Okay. So how should you balance? Should you change the number here or should you change the number here?
number as before.
Okay. So how would you change the numbers here?
Change H to 2 and then Cl to 2 also.
Woohoo! Cannot. You cannot change this. Remember? I said in the bonding part, you cannot change the number here. Yeah. So then how? Is there any other suggestion? Just remember that this hydrogen, let's say it's like that. Alright? Maybe a dad with a daughter. Alright? So they always have to be together. Alright? So then how? How are you going to balance it? Because there's only one.
Put a 2 there, right? Should be okay.
Put a 2 here. Yes, correct. So when you put a 2 there, it means that you are saying that it must be 2 pairs of this. Correct? So how many H are here now, Jisha?
2.
2, correct. How many Cl?
2.
2. So is it balanced?
Yep.
Correct. So that's a balanced chemical equation. Very good, Jisha. You done? So next I'll test Joshua.
Oh.
Oh yes.
But I need to confirm that.
Yeah, you copy down. Okay.
I didn't confirm yet.
So,
Still.
are you ready? Okay, Ready? Okay, let's just say that, let's say there's a, is that okay? So before and after. Okay, so Joshua, can you tell me how many lithiums are there?
2.
2. There are 2 lithium, huh? Okay, so how many oxygen are there?
1.
1 oxygen. How many magnesium are there?
1.
1. Okay. How many magnesiums are here? 1. How many oxygens are here?
1.
1. Huh? Then how many lithiums are there?
1.
1. So are they the same before and after? Why is it not the same?
Well, before there's 1 extra lithium, but after that,
There's only 1. So how do you balance it?
we add
Okay.
1 lithium.
We add 1 lithium more. Right. So how are you going to add 1 lithium more? You cannot write this. Add 1 more lithium. Put a 1 here. But if I want to put 1 more here, that's interesting. If I put a 1 here, it will still be 1, right? Are you sure it's 2? Okay, if you put a 2, then what happens? If it is 2, then how many lithiums are here now? 2. Exactly. So are they the same now? Before and after? Yes, they are the same. Correct?
Let me
Okay.
copy.
Chester, you copy already?
No.
I just love it. Yeah, so honest.
I haven't copied.
Yeah, Chester, I'm going to test you something harder now.
Aww. Oh my goodness. I think. This was also quite easy actually. For this, I don't know. What is NAT?
What's that?
Net.
Okay,
Net is a net.
so this is sodium reacted with water. You get sodium hydroxide and hydrogen gas. Okay.
Sodium.
Okay, so how many sodium are here, Chester?
1.
1. How many hydrogens are there? Very good. Okay, so how many oxygens are there?
1.
1. Okay, so how many sodium are here? 1. How many oxygen are here? 1. How many hydrogens are here?
2. Wait. 3.
3. Correct. Very good. Then how?
How much?
Very proactive. Very good.
Both of these times 2.
Which one you know times 2? Do you try times 2? You have to tell me. Then we can try. Don't worry about making mistakes. Which one you know times 2? This one. Times 2? Okay. That's okay. Then take a sip. Xavier? Is there any suggestions?
Put 1 in front here. Put 1 in front of the H2.
What's that again? Okay.
Put 1 in front of the H2.
Put a 1 in the H2O. Put a 1 H2O, it doesn't really change. 2. Okay. Always never afraid of putting numbers. Normally what we in O levels, you can try these numbers. 1, 2, and maximum is 3. Alright? So try these few numbers for O levels. If you realize that when you're balancing reaches 4 and above, this is not possible.
I've seen equations with 38 like that one.
Yeah, but that's not in O levels.
It's
Okay.
all in A levels.
Could be in A levels. So,
just like O level book for like A,
is it a pure?
I think so.
For combined chemistry, maximum numbers is 1, 2, and 3. So far, for the past 10 over years, for combined chemistry, this is the few numbers that you can try. Was it okay? But of course, if you are taking pure, then the numbers go all the way to 6 or 7. but 7 is quite rare already. Okay,
H2O.
let's take a look at here.
Why isn't there a O there?
Why is there O there? There's O here.
Oh.
Correct, right?
This one has two. Because that is saying that if this one has this one put 2, then this one put 3, then it will affect the others. Oops.
Very good, you are thinking, Jisha.
First, I
Yeah,
think
because
it's
if the H2O put a 2 in front.
Okay, so that's a suggestion.
That's why I also
So,
no, I touched.
remember about the tip that I mentioned last week? It's always balance elements last. The reason was because elements is much easier to deal with. So try to actually handle this and this first. So just now what Nathan suggested is a very good idea because you try not to disturb the sodium, you try not to disturb the hydrogens. So when you put a 2 here, okay, I'm going to put a 2 here already. Alright? So Chester, how many hydrogens are here now if I put a 2 here?
4.
4. How many oxygen?
2.
So 4 and 2, right? So now, what are you going to do now?
Then the NaOH put a 2 also.
No,
Is it the NaOH put a 2?
Why you want to put NaOH with a 2?
Then the hydrogen and the oxygen.
Yes, correct. So if you put a 2 here, alright,
it will affect sodium.
our objective is try to balance sodium and hydrogen last, correct? So when you put a 2, there's the oxygen is already disturbed already, right? So you don't care about the hydrogen, don't care about the sodium first. Look at what you need to balance. You need to balance the oxygen. So the oxygen there's 2, right? So I need to make sure that this is a 2. But I cannot put a 2 here, that's why I put a big 2 here. But okay, don't worry about the rest. Yes, there will be a changes. So Chester, how many sodium are here now? 2. Okay. How many hydrogens are here altogether? 2 for this side, and how many hydrogens? So together is how many? 4. Then how many oxygen? Oxygen, right? Yeah. So you should be very relieved if you realize that the oxygen that inside the compound is already balanced, because the elements can be balanced very easily. Why? Because yes, I realize that there are 2 sodium here, but there's only 1 sodium here, right? So I just need to put 2. Balance elements last. Your concern is those that is not an element, that means inside the compound. Challenging leh. Okay.
Interesting.
Can? Yeah.
If before write 2, after also must write 2 for the compound. Cannot 2 and then 1. Is it?
What do you
No, I
mean?
mean just I write 2H2O. Then after also 2 NaO.
The reason was because when someone suggested put a 2 here,
Yeah,
the
also must be-
oxygen already become 2, and there's only oxygen appears here, right? So my concern is I want to balance the oxygen first.
Also that number can be not the same.
Yeah, can be not the
Can
same.
be.
Yes, can be other numbers.
Wait, why is the hydrogen there is 4?
Huh?
Why is the hydrogen there for? Okay.
Can Okay, next.
Wait, am I done already?
Okay, Xavier. Hey, Xavier, can you tell me how many potassiums are here? 1. How many oxygens are here? 2. How many potassiums are here?
There's a like 2.
How many potassium are here? 2. Why is it 2? Yeah, there's a 2 here. Small 2 here is referring to the number or elements before that. So it means that there are 2K. Then how many oxygens are there? 1 O. Then how?
Okay.
So can you tell me, is this an element, Xavier? Is this an element? This is elements as well. If it's the same type, combined together is still known as the element. So this is known as element, this is known as a element. This one is known as a compound. Because why? Two different elements combined together. So your focus is which one? Balance this or balance this? Balance the compound. Alright? So you check, how many O are there? Then how many O are here? 2. So put a 2. When you put a 2, what happened to the oxygen? 2. Then what happened to the potassium? 4. Right? But elements, no worries, because elements can be balanced very easily. What should you put the K here? 4. Awesome.
So over there should be.
Very good. Huh? Yes, Joshua.
Over there is 5.
But over here become 4. Correct. Can?
I'm gonna have wrong. There's no chance.
60x.
What do you see the second one? Is it 6.0 or 16?
There's a point there.
6.0 times 10 to the power of 23.
6.0 times 10 to the power of 23.
I don't understand what that is. It's not perfect.
So actually 16 grams of oxygen, let's say, then you go
Power
to
of
6 times 10.
How is it possible?
Chester?
I think it's out of his mind. Though I don't even understand. Oh no, you already drawn this. I'm still doing this. I'm still
Eh, what is 1.0?
Okay,
perfect.
your turn. I don't plan to start anything yet.
See what you see. Why do we
Yeah.
What is CO3?
Okay.
This is more concept.
I thought still got a hard one.
Including the parents. So this is what I'm going to do. You have one stack, right? Correct. There's 4 pages, right? So just now, who actually get correct for both worksheets? Only one person, right?
Eh, no, Ethan also.
You got both, right? So Nathan and Ethan.
I got one wrong only.
Who only get
My second
perfect?
one is not perfect.
Who get perfect only for one worksheets?
Me.
3 years. Xavier and Chester, right? And the rest, right? The rest is, which means there's Nick, Joshua, and Zach.
Too hard.
Okay.
Okay.
Okay. For Nathan and Ethan, on top of that, the 40 questions that you're supposed to do, do this extra challenging level.
At least this one is
Okay? And one more.
The first one I
Ethan. Yeah, Ethan.
Ethan, you still need to do one more. Oh boy.
Oh, I
I think I didn't get perfect. I'm so
Okay.
happy I get perfect.
Okay, Chester, Zisha, and Xavier, right? You all do the current this. This. Yeah, this for homework. Okay? Then for the rest, Nicholas, Joshua, and Zachary. Try the first 2 pages.
No.
Alright, but Nicholas, I'll encourage you to do all.
Hooray!
Was it okay?
No, okay.
I'll still give you these two pieces if you want.
Okay.
So I repeat again, for Nathan and Ethan, you all have at least 60 chemical equations to balance. That's your homework. Trisha, Xavier and Chester, you all have 40.
No.
Alright? And then the rest have 20.
No. Hey,
Was it okay?
Wait, 20 what?
The first two pages.
Oh,
okay. So good.
so not good.
Huh?
Wow.
You want the challenging one?
Why so fast? Then let me just copy down my moon first.
Holy moly.
Okay. There are two ways of how you can memorize the formulas. Some prefer to memorize them as just follow this, alright? Or some prefer to memorize as the individual's formulas, alright? So it really depends on your preference. Either you want to memorize it in this way, I'll explain that why this triangle looks so much simple compared to this later. Or you can choose to memorize individuals' triangles. Alright? So if you recall in electricity, even though we haven't covered finish,
This one I only see 3 triangles.
yeah, strange, huh? Why 3 triangles now can become 5? Huh? So I'll explain later. So some people they prefer this because the focus is always the mole here. Alright? So what is a mole?
The red thing. No, the
Oh, the mole, correct. Huh? There's an animal that's called a mole,
the
right?
one that
Mole
got
on
the
the face.
thingy.
Yeah, yeah, correct. There's also something that grow from your face. Alright? Depends on which part. Some people think that it's sexy. Some more? What other things that you can think of? One mole. The word mole itself. Like for example, it could be a spy. So like they planted a mole in the enemy camp.
Oh
So-
yes, mold. The red mold that grows on.
Oh, that's M-O-L-D, right? Mole. Okay.
Sometimes they
But however, it's nothing of that sort. This mole is actually a word that representing a number, and oftentimes we do use that in English. For example, when we say one pair, we say that it is 2. And we say that when it says 1 dozen, the word dozen means it's 12. Correct? There's others as well, like 1 ring. Alright? But for 1 mole, the number is 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So 1 mole, if I have 1 mole of 1 cent, I can buy a few countries. Basically, you can see that this is really a huge number. And it makes perfect sense because all the things that you are measuring, for example, hydrogens, oxygens, all these are very small. So you need so many of them, then they become heavy enough that you can actually measure. Okay? In fact, this word, when they say 1 mole of hydrogen gas is actually 2 grams.
What?
1 mole of oxygen gas is 32 grams. 1 mole of sodium equals to 23 grams. Can you actually check in your periodic table what's so special about all these numbers?
I don't know.
我是用表演这个。periodic table leh.
Do you have periodic table?
Oh, it's a multiple of the on top number.
Yes, correct.
Yeah, good David, I thought this periodic table leh.
Okay.
I can borrow you.
I can lend you.
I can borrow this one.
Now here. You have? Okay. Can you all see what's so special about this when I say 1 mole of hydrogen gas is 2 grams, 1 mole of oxygen gas is 32, 1 mole of sodium is 23 grams. So where does this number come from? Can you actually check from your periodic tables?
Yes.
Right, it's actually, if you look at hydrogen, hydrogen's here. So this one, the oxygen and sodium. Can you all see that this number, okay, because there's O2 here, so you take this number times 2. Then, because there's 2 here, so 1 times 2 is equals to 2 grams. So that's why this number, this number has a name. This name is Avogadro's constant. It's not the fruits. This Avogadro's is a guy who thought of this idea that we can actually measure all these elements using a specific number. Yeah, he's supposed to be a genius, but he was recognized as a lunatic during his era. Only when he died, people realized that what he says is correct. Sometimes that's always the case. So, I think that's why I don't care what people say. You think that that's the correct thing to do, then just do it. Yeah, because oftentimes people don't recognize. It's quite sad. He has a very sad life. Yeah, just like Van Gogh. Okay, so yeah, mango. Okay, so that's why 1 mole of hydrogen gas is 2 grams, 1 mole of oxygen is 32, and it's actually coincide with this number of this atomic mass. So that's why they pick this number. So this number is not anyhow picked. Alright, they pick this number because if you talk about 1 mole, you literally know what is the actual mass of that particular compound. Okay, I'll give you another example. Can someone tell me what is the mass of 1 mole of water? Check in your periodic table.
16 plus.
Very good, Chester. So it's 18 grams.
Why? Oh, because 2 plus 6.
Correct, 2 plus 16, because there are 2 hydrogen, then plus oxygen. So 1 plus 1 plus 16, that's why it's 18. Can? Okay. So all these formula that you see will be used in your chemical equations. That is why balancing chemical equations is the prerequisite. It's a must that you must know how to balance. Because if you balance wrongly, the rest of the calculations, you will lose at least 50% of the marks. Okay, there's such thing called this. Normally they will have this thing in the marking. They put ECF. Okay, it's known as a error carry forward. Which means that if you make an error in the very beginning and you use the wrong value to proceed with your calculation, they will still mark the workings. So of course they cannot give you the final answer marks.
Then how much more?
So if it's 2 marks questions, then you only get 1 out of 2. But it's better than getting 0, right? So that is why it is always important in your calculation, you write down the formula that you want to use, write down in your answer. Alright? For example, if you think that in these particular questions, I'm going to use this formula, write down the formula onto your workings so that they can give you working marks. Was it okay? Try to make this a habit. Okay? Are you all done copying all the formulas already? Okay, this part done?
Yes.
No, not the and not the mole.
The guy who has such a weird shape.
Okay.
But that side is done.
Which one is done?
That's it.
All these are.
Yep.
Yeah,
Okay.
Van Gogh, Vincent Van Gogh.
Mango's number.
Van Gogh. Why is it called
Okay.
Vincent? Because I like Moses.
Before I wrap it off, let me just go through the formulas one more time. Okay, this particular triangle, it can be used for all physical states. What do you mean by physical state? In chemistry, there's 4 physical states. There is a solid S,
Solid, liquid, gas, and fluid.
solid, liquid, yes, the other one is liquid. There's another one, it's called AQ, it's called aqueous, and G is for gas. So this particular formula, it can be used for all physical states. Okay? The triangle at the bottom, this triangle, can only be used for liquid or aqueous state. So if you have a different colored pen, it's good to just so that you won't get so confused. And the last one, this one, it can only be used for gaseous state. Gas.
And what?
Aqueous. Aqueous. Just as physics, we are very particular about the units. Alright, we are very particular about the units. In chemistry, we also are very particular of the units used. For example, this mass, it is in grams. Alright? And for you all that have not learned, because I haven't really teach in physics, the conversion of the units, maybe it's good to write it down, like 1 kg is equals to 1,000 grams. Alright? 1 ton is equals to 1,000 kilograms. Therefore, 1 ton is equals to 1 million grams. Can? No. So if you have not learned this yet, I would advise that perhaps it's good for now, just copy it. I'll teach how to do the unit conversion next week. Alright. So what is this MR? Mister.
Mr. Man.
What is MR? Actually, MR stands for molar mass. Alright, it stands for molar mass. So people say, what is molar mass? Then people will say that it is a relative atomic mass. Then people also look very blur. Some people say, oh, this is relative molecular mass. They look even blurrer. And they say that this is actually relative formula mass. They say, I don't understand what you're talking about. And actually in the end, they say that actually this is just a mass number. And they still don't understand. They say it's nuclear number. They still don't understand. Then they say that actually this is a number on the top on your periodic table. So that's molar mass.
So which is correct actually?
All are correct. It's just that how simple that you want it to be. And I will give you all, I will have to explain all these things later. 23.
Then I put in.
I draw already.
Okay? let me tell you a very absurd history of this thing called the relative atomic mass. You all have learned this already, relative atomic mass, when we first started learning atomic structure. If you recall, we learned about how many subatomic particles are there. There are neutrons, there is protons, there is electrons, correct? We say that this one has no charge. We say that this one has a positive charge, this one has a negative charge. We say that this mass is 1, this mass is 1, this mass is almost close to 0. And sometimes I use the words, it's actually 1 over 1843. But in O levels, 0 is accepted. Alright? But what is it 1? Why is it 1? Okay, the history goes like this. A long time ago, actually it's not very long now, so just 100 years ago, 100 plus years ago, people are wondering how can you measure things like hydrogens, oxygens, sodiums and all these things. Alright, because it's so light, you cannot use a normal weighing machine because you can't read. Alright, so then they say, okay, how about this? They found out that hydrogen is the lightest element in the whole wide world. So they say that I'm going to use this to compare. So imagine it's like that. I think it's like that. So here, they put one hydrogen here. They put one hydrogen here, and then they put, let's say, oxygen. And they realize when they put one oxygen here, and what happened? The balance becomes like this. What does it show when it actually goes like that?
Oxygen heavier.
Huh? Oxygen is heavier. So end up, what do? They start putting another hydrogens, and in the end, they found out that to balance it, you need about 16 of the hydrogens to balance one oxygen. Okay, that's what you call relative mass, because this is not the actual mass. Basically, they say that, let's say that hydrogen mass is 1. Everything else compare with hydrogens. Alright? So what does this mean? It means, why is it 16? When 16 means that this oxygen is how many times heavier than hydrogen? 16 times. Why is it 23?
It's 23 times heavier than hydrogen.
Okay. So everybody is happy. So the modern periodic table was born. So not long after that, there is this group of chemists. They say, actually, hydrogen not very accurate. They say carbon very accurate. So okay, so means that they're going to change that everything will compare with carbon. So carbon before that, carbon is this. So carbon, this is carbon. So they say that okay, now change this to 1. Alright, so everything else must compare with carbon. Do you know what happens when you change everything else to carbon and everything compared with carbon?
The whole pyramid.
What happened to the periodic table to the hydrogen? The hydrogen will become 1 over 12. Then what happened to the oxygen? Will be 16 over 12. Then how about sodium? You become 23 over 12. Correct? Because you compare with, you use carbon as a comparison. Correct? So that's a problem, right? Who like fractions? I personally don't like fractions. Okay, so a lot of people boo this chemist. They boo. They say this is stupid. Then this chemist, this group of chemists is he's quite influential. They say, okay, how about this? This carbon, this is the carbon, right? You divide this into 12 parts. 1, 2, so 12 parts, right? How do you go with 12 parts? The 6, is it? Then, okay, then you just take one piece out of that and then you compare with the rest. So it means that now you compare with 1/12 of carbon 12. So wouldn't that mean that it's back to normal? So this one will become 1 again. This one is 16. And this one becomes 23.
It's history.
Isn't this the same as comparing with hydrogen in the first place? It's weird to the... It's weirdness to the max. That's the history. So that's why when they say relative atomic mass, alright, not to worry, I'll pass you the notes next week. Relative atomic mass is basically you compare the mass of the element with 1/12 of carbon-12. You're no longer comparing with the hydrogen, but you're comparing with 1/12 of carbon-12. Don't ask me why, because it was decided in the history. Yeah. So these are all the so-called smart people, but appear like quite gundu also in the end.
How does it know that hydrogen is actually 1? How is that? They say hydrogen is 1 and then...
Oh, they found out hydrogen is quite light. Hydrogen is the lightest thing, so then it's only logical to compare with hydrogen. Correct? So because it's lightest, so if it's lightest, it makes sense that you compare everything else with hydrogen. But then something happens along the history.
Wow.
Yeah,
是
it's 238 times heavier than 1/12 of carbon-12.
So this one you have to learn one.
Definition, yes. You have to learn the definitions. You'll be given, let's say, normally in an exam, there will be at least 5 marks questions on definitions.
You have to explain why.
You're supposed to tell them what is the definition. So they say define molar mass, or define relative atomic mass, or define the relative molecular mass.
So just write down what
You just memorize
said
and then just vomit out what you memorize. Yeah.
Maybe you didn't memorize the whole history of it.
No, history part of it. Because a lot of people wonder why you are comparing 1/12 of carbon-12. It doesn't make sense, is it? Because 1/12, 12 is actually 1, which is hydrogen. There's a history behind it. Was it okay? Okay. So once you are done, I will pause. We will continue next week. I have to discuss your homework. Okay.
Oh, I think I forgot.
Do you all realize that for this question 3, you all requires 2 formulas? 2 formulas to get it correct. So basically, what are the 2 formulas that you are supposed to use?
QITEQ.
So you have to make use of the 2 formulas to actually get.
Over I. So Uncle David, I do the whole thing. Is it this one? Can we just
Yeah, we are now discussing electricity.
This one do the whole thing. Yeah, you do the whole thing.
Yeah.
But actually, my computer some of my homework. Yes, I also have.
And do you know, for this question 10, I put a cross on the question 10 because we haven't really learned the formulas yet. But yet, majority of you all seems to know the formula. I haven't teach yet power. So I actually took it out because the power we haven't learned yet. Power formula will be only discussed when we learn practical electricity. Yes, correct. The formula for the power is V times I. Voltage times current. But it seems like majority of you all seems to be okay. Just remember in your paper 2, when you attempt, I really need the workings. That means, what do you mean by workings? What do you mean by working? When I say I need workings.
Is it the
Correct. Please write down the formula that you are going to use. Alright? Please write down the formula that you're going to use. That's why the presentations. Okay. For example,
I think I wrote down my formulas for most of them.
yeah,
Where's your paper?
but there are some.
Yeah, that's why.
Okay. So for example, let's just say that you want to use this formula, and let's just say that it's V equals to IR, right? Correct? So write it down, and then I'll say that V, then you know your I, which is 2, and the resistance, let's say, is 5. So V is equals to 10 volt. This is what I call workings. Which means that write down the formula that you're going to use, do a proper substitutions on it, and the final answer. Okay? Okay? Because the examiners, sometimes it's advised that if they write down the formula, if the candidate write the formulas, then they'll give them 1 mark for workings. Sometimes another year, they will say that it's not this or 1, I should actually only mark when they substitute correctly the values, then only they give 1 working marks. So to avoid V's, we just write every single step. So write down the formula you're going to use, write down the proper substitutions, and then the final answer. So this part will have, will have 1 mark, and this one will have 1 mark. Of course, there are some students saying, what if I have the correct answer, but I don't have workings?
They only give answer.
They will give you answer marks. Because here, these calculations is based on formula. So please write down your formulas and the proper substitutions. Is it okay? Try to make it a habit. And also it's better for me as well, because then I'll be able to notice what went wrong. Because if you only give me final answers, I'll mark you correct. But I cannot help you, because for all you know, you just pick a value and then just put it in.
Actually, I wrote my formula on top. Yeah, Nathan also wrote Nathan wrote his workings at the side. You never see it.
Huh? I won't consider that as workings. Alright? Yeah, like this with workings. Okay?
Everything wrong from no workings, but actually it's secret.
Okay? That's all. Is there any questions that you all have? That's the only thing that I wanted to highlight for your homework. Any other homeworks?
But there's one, there's one. I remember this is 2 and 4.
Uh-huh. Okay, you can, this one you can ask Nick. I think he got it correct. So you can. So what is your question?
Question.
This is the question.
Which question is there? Which question again? What is the question?
What is it? What's the right?
The fuse part, just leave it first, because I haven't teach yet.
Oh yeah, what is the difference between AM and PM? The question 2, the what? MA.
Okay.
Oh, AM at MAH.
Okay, there are some things that, for example, power, fuse, all these will be covered in the next chapter of electricity. Okay. Just as for the units wise, like for example, you see the unit look a bit weird, like milli. There's this thing like a small m there. Alright. Just ignore for a moment. We haven't gone through unit conversions yet. So whatever units that you put in here, I still mark you correct. This means milli lah. Just like when there's a meter, there's a centimeter, there's a millimeter, correct? They're similar for current as well.
Mother say also A, I say put MA. You just
Yeah, you will put MA, I still accept it. You put A, I still accept it, because we haven't learned the unit conversions.
And accept it. And also we put it around.
yeah.
Then this is the question. This one, we put it around.
Oh, because there's an answer here, same. Oh, okay.
Why has been broken?
Yeah, this one, okay, just leave it first. Next time we do the unit conversion, put a circle. Yeah.
After they read A B more for the row, A and B of all.
So is it
C.
Is it C or is it D?
C.
Okay, there is a question from Nathan. It's the last week homework, topic 16. Question 8.
Topic 16.
Ethan.
Yeah, last week. The last week homework.
Question 8.
Topic 16. Question 8.
Paper 1 or paper 2?
MCQ. Paper 1.
Question 8. Oh yeah.
Number 8.
I also got wrong.
I got correct. Just one.
Okay.
Should see, right? Yeah.
So a lot of people get wrong. He says here that
I like right there.
the current is 3 ampere. Okay, maybe someone can tell me the information.
A wire of length 1.0 meters has a resistance of 2.0 meters.
The first diagram is what?
Huh? A wire of length 1.0 meters.
The length is
1.0
1.0 meter,
has a resistance of 2.0 ohm.
2.0 ohm.
When connected to the cell, the current in the wire is 3.0 ampere.
Okay, so this is the first case, right? Okay, next.
A 2.0 meter length of the same wire is connected to the same cell.
Okay.
What is the resistance of the wire and the current in it?
Okay.
There.
So do you remember what formula should we use when it comes to wire?
Wait.
R equals to PL over A.
Yeah, we should use this, right? R equals to rho L over A, right? Do you all recall this formula? So therefore, when the length increases, what happens to the resistance?
Resistance is what?
Go up, go up.
Resistance go up.
Length. When the length increases, what happens to the resistance? I use the same illustration. I say if you were to run 100 meters and 1 kilometers, to run 1 kilometer will have more resistance, correct? So therefore, so this is 2 meters, right? So what happens to the resistance here?
Go up.
Go up by how much?
4 meter.
4 ohm,
4 ohm.
correct? So it's 4 ohm, right? Everyone get it? What happened to the current then?
Current should go down.
Okay, first and foremost, can I find out the voltage of the first case? What's the voltage? V equals to what? I times R, right? So it's equals to 3 times 2 equals to 6 volt, correct? So what is the current here by using the same formula? V equals to IR. So your I is equals to how much? 6 divided by 4, right?
1.5.
So it's 1.5 ampere. So do you understand?
Voltage remains the same.
Because they say they use the same cell. Hmm. The one is resistivity. Resistivity.
Resistivity. I don't know what is P.
Yeah, it's a materials resistivity.
What is it P? P doesn't stand for
It's rho, it's not P. Okay. Okay. Question 4. Jisha has a question. He says that which circuit can be used to find the resistance of the lamp. So basically these are just testing your connection. How do you connect your voltmeter? In what?
Parallel.
In parallel. How do you connect your ammeter?
Series.
In series. So therefore, this is not correct lor, because this is series. Yeah, so it has to be like this one. Yeah, sure. Anybody else have any questions?
Yeah, about it.
Okay. This is extra work done by Chester and Jisha. So majority of you all maybe have not seen this question. But it's the same worksheet. Can you all turn? Or maybe I encourage you all to try. Especially for Nathan and Nicholas. Yeah, this page. And this page. Turn again. Okay. So they say that, can you look at the question 12? They say the circuit diagram show identical pieces of resistor wire connected to the same cell in different ways. In which circuit will the cell lose its energy the fastest? Alright, so what is the key word for this? Question 12. Fastest. Yes, correct.
Yeah, I was thinking it's C at first, but I thought it has to be.
Okay, so just now Xavier said that the keyword that you are supposed to look at is fastest. So you lose heat, right? You lose heat the fastest means what? Is it like when you have a lot of resistance or when you have very little resistance?
A lot of resistance.
A lot of resistance. Why? Why is it when you have a lot of resistance you lose heat the fastest? Oh, okay. So what is a lot of resistance means? When you say a lot of resistance means what? What does a resistor do? What does a resistor do? What is the energy conversion for a resistor? Huh? Correct. It is actually preventing the current from passing through. So when the current has difficulty of passing through, wait, what does a resistor do? What's the energy conversion? Electrical energy to heat, right? So when you lose a lot of heat the fastest, that means that you have a lot of resistance. Why? Because you convert a lot of heat. Correct? So what we need to do is to find the total resistance. Okay, let's look at the option A. The option A is what? There's only one resistor, right? Is there a value given to that resistor? Okay, why not we put everything as 2? Is it okay? So if this 2 ohms, so what is the total resistance here? 2. Alright, let's look at B. So the B is what? So there are 2 resistors, right? So what is the total resistance, Joshua? What is it for? This is what series? What circuit is this? Series. So this is 4. Okay, so what is the next? The next one is in parallel. So parallel, how to do?
Yep.
1 over R total is equals to 1 over 2 plus 1 over 2. 1 over R total is equals to 1. R total is equals to 1. What's the next one? What's the next one? There's a parallel. And then after that it will be series, correct? So I know what is the total resistance here, right? This total resistance is how much? 1. So I can convert these circuits into this, which is 1 ohm, and this one is 2 ohm. So what's the R total? 3. So what is the answer? The answer is B.
Oh, that's okay. That was C.
I wrote C, but I was wrong.
I wrote B.
Oh no, not supposed to do.
Why is it?
These are the extra work that they did.
What about, I think, 11?
Wait, what we calculate?
Total resistance. You
Should I do?
Any more questions? Because this will be the last time we discuss electricity before your test. We will not have enough time because for chemistry I still have to cover more. So any questions? For your worksheets?
11A.
Huh? Oh yeah, actually next week we still have about half an hour to discuss your current homework also. 11?
11 is B, right? Is B correct?
Huh?
Is B correct?
Oh, I think so. Okay, can you all turn to question 11 also? Nicholas, Joshua, can we look at the same questions again? The previous question, question 11. They say the diagram shows a cell connected in series with emitter of 3 resistors, 10, 20, 30, and then after that there's a contact, and then after that when connected to X, the emitter reads 0.6. So what happens when they connected to Y? So maybe I just draw it out lah. I think I'll rub this off already. Okay. Okay, let me just draw out the diagrams. I think this was done before we actually go through in details the DC circuits. So this one is X, this one is Y, this one is Z, this is 10, this is 20, this is 30. Okay? So they say that when they're connected to X, correct? So it means that this connected to X, what's the reading of the emitter? 0.6. So can I calculate, just based on this calculation, I can calculate what's the voltage of this. What's the voltage? What's the formula for the voltage?
Voltage is 10 times V.
10 times. So V is equals to I times R. So it's 10 times 0.6. 6 volt.
6 volt.
6 volt, right? Okay. So now I'm going to change the contact point. Okay. So I connect it to here now. So is this the same cell? Are we talking the same cell? Is the battery used the same? Do they say that they changed the battery? They only changed the contact point only, right? So they only change the contact point means that the cell is still the same. If the cell is still the same means what? The voltage are still the same, right? But what is different now? The resistance has changed, and if the resistance has changed, what happened to the current? Change as well. So what is the total resistance now? 10 plus 20, so it's 30 ohm, right? Correct, Nathan? So how do you find now the new A? So this A is not used already. So I is equals to
6 over 30. 0.2 ohm. Did you write down?
Okay? Do you all understand?
Yeah, 10 plus 20.
Now, what is it 10 plus 20?
Because the two resistors.
Correct, there are two resistors in series.
Oh, I thought in series current always the same.
In series, but then because now, because once you move the contact point, the total resistance has changed. So that's why your total current has to change as well. Correct? It's quite a tricky question for this.
Yes. 0.3. Wait, how can I get 0.2 at first?
Oh yeah.
Well, at first
Does the current affect the usage of the cell?
That's
The, like, let's say more current,
more current.
because if it is in parallel, that means the current is faster, right? The rate of current is faster already.
The current is more, you mean?
Yeah, more current.
Uh-huh.
Does it affect the lifespan of the battery?
Yeah, it does.
So more current means faster.
Actually, power loss, which you haven't learned yet, you learn this formula in magnetism, which is like a few topics after electricity. It's actually given by I square R. So higher the current, more power loss.
More power loss. That means the battery will be used up faster.
Correct.
So in that question there,
Mm-hmm.
in a parallel, the previous question,
Number 12.
yeah, the question 12 there, the resistance lower means higher current, right?
Resistor lower. Oh, you are talking about
Yes,
this.
yes. Lower resistance means higher current, right? Then if higher current, does that mean that the battery will be used up faster? Energy loss is energy loss equals to lifespan of battery.
Oh no, they are talking about the whole circuits, not the source here.
Oh.
Yeah. They're actually talking about the whole setups from the resistor perspective, not the source.
Okay.
Yeah. So normally for power loss, there will be some adjustments of the understanding, but for students we will just look at the circuits, this part only, the arrangement of the resistors. Okay? Any more questions?
Teacher, I'm correct at once.
Okay, can teacher? So
I think.
Teacher, any more wrong?
Yeah. Decreasing resistance.
you have to check the graphs that the notes that I'll pass it to you. Then you see whether it's there error there. The error is the graph is opposite. You check back in your graphs, especially the axis.
Only the I should be on top.
Right. The axis is wrong. That's why the shape of the graph is wrong also. You do the correction and then pass it to me.
The I must be the same.
Okay. Any more questions? No, huh? Okay, so for next week, we will still continue discuss DC circuits because this is the last time, right, that I give homework on DC circuits. You all still have, alright, you all still have extra DC circuits homeworks, right? Worksheets that are passed to you all. So if you all have the time and you feel that you needed more practice, you can just take out the worksheets that I have not assigned for any one of you to do as a homework. You can try.
You mean the 18 and chapter 18 and chapter 17?
Is there any more left?
I did the extra ones.
Okay, so David, so what's the homework for today?
The difference. What you want more? Yeah, you still got extra. You 60 questions.
And then the DC circuits need to do or not?
For the DC circuits, you all actually still have one particular worksheet, which is topic 15. If you all feel that you need, if you feel that you need extra, so that you can understand better, you can do it. But this is not a compulsory homework. Was it okay? Because I feel that my focus this time around should be on your chemical equations.
Chemical equation is also in the exam, huh?
Yeah.
Everything.
Okay, so there is no game today because there are so many things that we need to cover. Hopefully next week we have some time to do something fun.